Hi, this is Mr. AB, right here. Please subscribe if today is the first time or if you haven't subscribed so that you can see all my lesson videos that I have already made. Check the playlist for all the topics that you needed: slope, quadratic, exponential, trigonometry, and all that. Here, we have been asked to model the exponential function. From the data below here, there's a bacteria growth. So here we know is a growth. So the general function for exponential is y is equals to ab to the power x here. And we know that the a is the start point, and the b is the rate of growth or decay, and the x is the time. So in this situation, they have been using the t and p. The population has been given, or this p has been given as a b to the power t. We are using the variables given here. So here we know our start. The time zero was 200, so that means a is 200. And then we gotta figure out the b, which is the rate. So since we know is a growth, we can use the population to see what is happening. So from here to here, and then here, you have to be a constant ratio. So what we could do is that we can say that, 600, for us to get a b, which happens to be the rate, we can say 600 divided by 200. And that gives us, you cancel the zeros, you know that you get 3. And check one more to be sure of. 1800 divided by 600 also give us 3. So here the 3 is a constant rate of growth. So therefore we can conclude that P, with a starting of 200, and then its growth rate is that P is the starting is 200, and then the rate is 3 to the power t. So this can able to help us to estimate in any given hour what is going to be the population of the bacteria. And so here we have it on a graph. So we will still using the module y is equals to a times b to the power x here. Here we realize that it's asymptotic, is approaching 0. So kind of sometimes we have c over here. So in this situation, the c is 0. So we don't need to worry about that. So we need to, at 0, one number is here. This number is 3. So here we could see the initial. We see our a to be 3. Then let's figure out the edge, of the edge here. So here you see the edge over there, and when it's in the middle here, which is 1, that does give us 1. That also give us a little 6 here. So let's see, we got, so here 1, 6, and now when it's 2, 12, and here when it's 0 is 3. So we can able to find the rate. How can 3 became 6 and 6 became 12? So here we realize that it's times 2, and here is times 2. So the rate, which is the b, is 2. So we got everything. So we can able to write this exponential graph as 3, and the growth is a growth here, and it's to the power x. That's the exponential function for. So here we have been given points, 2 points, and the asymptote to be 1, which is a C, and they want us to write the module right here. So what we have to do, we have to write the standard exponential function, which is y is equals to b ab to the power x plus c. So here we have been given c to be 1. So what we have to do is that at point 0, 3, remember this is x and this is y. So we plug it in here. 3 is equals to ab to the power 0 plus 1. That's our first equation. And then at -2, 9, this is our x and this is our y. We got 9 is equals to a b to the power -2 plus 1. And this is our, so from the first equation, and we are also dealing with the exponent, we know that any number to the power 0 is 1. So from this equation 1 here, we can say that 3 is equals to a times 1, because b to the power 0 is 1, then plus 1. So here we want to find our a. What do? We subtract 1 here and do the same thing here. So we got 2 is equals to a. So we got our a to be 2. And now what we have to do is that we have to solve our b from the second equation here. So from the second equation, 9, we know that b, this to the power -2 can be written as b to the power squared here. So here become a, and this come here as squared, and it's plus 1. So we subtract 1 on both sides. So here -1 and -1. That give us 8 is equals to a b squared. But we know that a has been found to be what? 2. So we got 8 is equals to 2 over b. And then we can bring this here and then bring this one over here. So b is 2 over, okay, is b squared. Okay, so we can, b squared is that equals to 8. That give us 1 over 4. This simplify as 1 over 4. We get b squared as 1 over 4. And what do? We take a square root on both sides. So we take a square root here, and we take a square root here. And that implies that we get b is equals to square root of 1 is 1, square root of 4. Here we are looking at the positive side of it, and it's 2. So we got b to be equals to 1/2. Now we have everything, so we are bringing it back here, so we can write y is equals to, we got a to be 2, so the initial is 2, and here we got half to the power x plus 1. So here we realize that this is going to be a decay, because the rate is half, it was halving all the time, so this is going to be a decay with the initials starting with 2, and it's asymptotic, not to 0 this time around, but it's asymptotic to 1. We write our general formula for exponent, a b to the power x here, and here plus c. But they are telling us that the c is 0. So simply we got y is equals to a b x here. At the point 1, 6, this is x and this is y, will give us 6 is equals to a and b to the power 1. And then at 354, this is x and this is y. So we're going to get 54 is equals to a b to the power 3. This is equation 1 and this is equation 2. So what we can do is that we are looking for, we want our A and we want our B. So what we're going to do is that we're going to say we are dividing equation 2 by equation 1. So I'm writing this one first. So here 54 divided by 6, and then A, B, cube divided by A, B. Also, B to the power 1 is the same as just B. So here we got 9, and this cancel that. And here, even let me maintain the 1, and you see that the powers, the laws of exponent, if we have B3 divided by B1, it's just B3 minus 1, and that will be B squared. So here will be just B to the power 2. Now we are looking for B, so we will take a square root here, and we will repeat the same thing here. And here we are looking at only the principal, so that will give us 3, and that will be B. So B is equals to 3, and then after that we substitute B equals to 3 into one of the equation, but let's put it in the equation 1. That will make it simple. Equation 1. So 6 is equals to 3A. We divide both sides by 3, and then we get our 2. So now we can write our final model, our final exponential module, our model to be y is equals to 2 times 3 to the power x. So here, since the rate is more than 1, is a growth, and the initial is 2. So let's look at this last example from the graph. We want us to write exponential function for this graph. We write our standard our standard exponential function, which is y is equals to ab to the power x. Here is asymptotic to 0, so there's no c number here. We look for our point. So at 0 is 2. So 0, we got 2 here. And at 1, use the middle here, is 8. So 1 at negative 1 is 8. So here we see that there is a decay. So it's dropping down. So for us to see we know our A is equals to 2. For us to get our B, we know that it started from here and it's coming down. So for us to get a ratio between these two numbers, the bigger one have to go up, so 2/8, and that gives us a quarter here, 1/4. So our B is just quarter. So therefore, our module is going to be, for this graph here, it's going to be 2 quarter to the power 8. And this is a decay because it's less than 1 and it's decreasing, it's coming down exponentially. Please, thank you for watching. If today is your first time watching my videos, my lessons, please subscribe and see you in the next video. Be blessed. Bye.